Hello everybody, welcome to part 2 on how to do the modulate assignment. We're now going to be talking about type 2 cations and single element anions. Alright, so let's look at the first example, CuF. So I'll redraw it over here, put a space between them so I have room for the charges. If I take a look at the chart on page 2 that I told you about earlier, we've got an F with a -1, that's a -1 charge here. That means that the charge over here has to be +1 because these guys have to match. -1 +1. That puts a plus here on the copper. So the name of this would be copper 1 fluoride. Alright, so why did I put the 1 in here? I put the 1 in here because copper is a type 2 it's a type 2 cation, which means that it can have more than one possible charge. So I put the 1 in here to indicate that the charge here is 1 plus. How do I know if it's a type 2 cation? Well, what I do is I take a look at page 2, and those are all listed here. And as you can see, copper could be 1 plus or 2 plus, and it's important to include in the name whether it's going to be 1 or 2. And we do that by using the Roman numeral, as I showed you earlier. Right here, copper 1 fluoride. That 1 is there not because there's only one copper, but because the charge is 1 plus. Well, let me show you why it's important. Let's take a look and see what happens if we have CuF2. Cu, 2 Fs, negative, negative. The total here is -2, which means that the total positive has to be +2. What that means is the charge on the copper now must be 2 plus to match the negative charge we have on the fluorine. The name of this one would be copper 2 fluoride. The 2 here because we have a 2 plus charge on the copper. And that's why it's very important to include some kind of indication in the name as to what the charge is going to be. So this one's copper 2 fluoride. The previous one was copper 1 fluoride. So going back to the assignment now, in here you'd put Cu 1 plus, F 1 minus, and the answer would be copper 1 fluoride. Alright, let's take a look at the next one. We'll take a look at this one, Cr2O3. Oh, this one's a little bit tougher. Okay, so let's go back to our whiteboard. So what I do is I draw a picture. We've got 2 chromiums because I've got 2 there. We've got 3 oxygens. Each of those has a -2 charge. There we go. Total -6. Now, what we know is that if that's -6, then this has to be +6 to match, because these have to match, -6 and +6. Now I've got to figure out, well, what charge do we need on each chromium here to get +6? Oh, okay, so I guess I'm going to have to put a 3 plus here and a 3 plus here. So now we've got a total of +6. The name of this would be chromium 3 oxide. The reason it's 3 is because we're talking about the charge on each chromium, which is going to be 3 plus, not 6 plus. That would be the total charge. But it's chromium 3 oxide, Cr3 plus. And then on the assignment you would write Cr3 plus, O2 minus, and the answer would be chromium 3 oxide. Well, let's look at the next one, CrO then. Drawing a picture, Cr and O, just one of each. Oxygen has a negative 2 charge. The total positive charge must be positive 2 because those have to match. Now I put on Cr2 plus because that has to match the charge that we've got here. So we've got chromium 2 oxide. Different compound to what we just dealt with, because now the 2 here is telling us that we have a positive 2 charge on the chromium. Well, this concludes our discussion of type 2 cations and single element anions.